Hi everybody, this is Mrs. Mancuso, and the first video we are going to do is on atoms. So here's our reference table. We can go look on the periodic table, and here are all of the different elements. So if we want to talk about an atom of any one of these elements, let's say sodium. So there it is on the periodic table, and what it tells us is that an atom of sodium has an atomic number of 11, and it has a mass of 23. So let's talk about what's inside this atom. First of all, 11, the atomic number, is always what identifies an element. It tells you the number of protons, and protons are positive and they're in the nucleus. So here's my nucleus, and it would have 11 protons inside of it. The mass tells us the overall mass of the atom, and the mass is just in the nucleus. Electrons' mass is negligible, which means it's too small to consider. So what I can do is say 23 minus 11, so all of the mass minus the 11 protons will be 12. So that means there's 12 neutrons also in the nucleus. So I put 12N. So there is my nucleus. It contains the protons and the neutrons. So overall, its charge, it's called the nuclear charge. The charge is positive 11. The neutrons don't have a charge, so those 12 don't count, but there are 11 protons, so that gives it a nuclear charge of 11. Now, the majority of an atom is empty space. And in this empty space here are going to be 11 electrons. So the positives and the negatives have to be the same number when you have an atom. So in an atom, the number of P's equal the number of E's. The positives and negatives balance out, and it has no charge. So again, I go back to the reference table, and here's Na, and here's 11, and under 11 it says 2-8-1. 2-8-1 is its electron configuration. So that means the very first orbital around it would have 2 electrons. And I draw them further apart because they're both negative, so they're not attracted to each other, so they spread out. The next orbital would have 8. 1, 2, 3, 4, 5, 6, 7, 8. And the last orbital would have just 1. So that's its electron configuration, 2, 8, 1. We know that these rings make us think of Bohr. He's the one that proposed the model, the planetary model, where you can find the electrons in orbitals outside the nucleus. And we know now that it's more like an electron cloud. So we got 11 protons and 12 neutrons in the nucleus, and then we just have all these little dots. And these are in regions that we still consider orbitals, but we say this is the most probable location of an electron because it's moving as a wave, not exactly on perfect circles. All right, and now I want to talk about that 281 one more time. 281 is the electron configuration, and that means that's what it is normally. Now, when an atom gets excited, excitement can happen by light or a flame, but you definitely have to add energy in. Energy is added. So here's my 11 protons, and here's my 12 neutrons in the nucleus, and here's my 2 and my 8 and my 1. So if any of these electrons get excited, 1, 2, 3, 4, 5, 6, 7, 8. So I have 2, 8, and 1. Okay. If any of them get excited, they could actually move out. So I'm going to pick this one right here, and it could move out to this outer orbital. My new configuration is 2-7-2. So that's excited. All right, and so an excited state represents what happens when light or heat is absorbed by electron and it moves away from the nucleus to an outer energy level. These energy levels have higher energy, and the ones closest to the nucleus have lower energy. All right, and last, I want to talk about one more thing. it never stays out here. It doesn't have enough energy to stay in the outer orbitals, so it always falls back to ground state. So ground state was my normal configuration, and my excited state was 272. Now when it falls back to ground, it releases energy. When it releases energy, that's seen as spectra. It's seen as colors of light. So it releases a specific spectral pattern, and you can actually go back and identify an element by its spectral pattern. All right, join me again for more chemistry review.